try to talk to you about the subject that is very interesting for myself, but probably not so practical for your work. I want you to forget about enterprise development, AI hype, everything that is like you learn like for the other sessions, and just to enjoy today, like something beautiful, and maybe it will inspire you to do something else besides, just regular coding, and maybe you will get a different perspective on programming as well. So creative coding is the subject. My name is Anton. I work for JetBrains in advocacy team, mostly programming in Kotlin, and therefore I will be using Kotlin today, but that's not the primary focus of this talk, because you can do that with any language. It's just, the important part is the approach that you take there. So when I say creative coding, the term, what it means for you? What do you mean by creative coding? There is a definition in Wikipedia. I'm not really agreeing with that one, like doing something for creative purpose without any functional goal in mind. I think art actually has a purpose, but well, everybody has their own definition. And creative coding is very often about creating some attractive visuals, but not only. There is more to that. So for instance, this screenshot here, the background, is created by a creative team, the computational arts team at JetBrains. They have a lot of interesting open source projects that they host at GitHub, and you can generate your own visuals as well. But it's very often about some kind of a geometry, so like curves, other figures, and so on, and combination of that. So abstract art, geometry, figures, everything of that kind. And when I ask you, what is the most famous geometric drawing that you know in existence? What comes to mind? Circle? Fractals? What else? Black square. Black square is actually the most famous picture. If it's actually interesting to know how it appeared. It's not an art history lesson today, but assume that we are looking at this a square now, and you know who the author is? Malevich. But do you know that this is just one picture of the component that has been reused in many other artworks that he produced? So there's a lot. And it's just one component that he reused in other works as well. But let's take a look at that square a little bit closer. This is just like a picture I found on the internet, but let's do a few transformations with that. Let's make it really black, right? Remove the canvas. There is a black square geometry figure. And the simple geometry figures, actually you will be surprised how many of them, if you start paying attention, how many of them are on the streets in various designs. Take a look at the logos that companies have, and so on. So does this remind you of anything? Anyone? There's a person sitting in the T-shirt where this logo is exactly depicted. I don't know if it's on purpose, but I just saw the connection right there, right? And that's just the black square. But if you look around at the streets, how the posters are made and so on, you will actually find a lot of interesting, very simple geometric shapes being used to compose them. And but we will not talk about squares today. We will talk about something else. I want to tell you a little bit of a personal story. I have a hobby since 90s when I was a kid. I was drawing circles. like literally just circles and combinations of them. I have some artwork exhibitions done as well with them. Some people buy them, but, well, it's just a hobby. And this hobby is like a meditation, I would say. You draw something with a circle, like with a pencil and that tool right there. And there is more. And I actually do have an Instagram account for that. And some people ask me, how do you generate? What programming language do you use to generate those tools? This is my programming language here, right here, this one. I have some footages as well. This is how it looks like. But this is a very simple shape, right? You can do that programmatically. So what's the goal right there? Getting something that is pixel perfect on the paper or on the screen, or something that looks slightly offset. It has small mistakes as well. Sometimes the circles are not perfect, and so on, out of the function that it follows, and so on. So today I want to check, first I want to check your math knowledge first, if you remember anything. And then we do some live coding and see how you can actually use programming language and those approaches that I do manually without math. But, well, if you program something, you will need some math. And how can you escape that as well? So, a circle, very simple shape, right? You can take the circlet, or how you call this tool. Anyways, compass, it's a compass. Draw a compass, and then how do you know the position of the point on the circle? How to calculate that? Do you remember some school math? Sine and cosine, right? So you need to convert to radians, actually. To calculate the offset for the x coordinate, you need to multiply the radius to the cosine of those radians. Same for the y-axis, and you get a position of the point on the circle. And we can do the same for the next one, can do the same for the next one, just changing the angle right there, right? It's a manual thing, but this is like a straightforward and, let's say, naive way of calculating those points on the circle. And once we have those points on the curve, on the circle curve, it means that we are actually iterating. It's an iterative process. So when someone is talking to you about generative arts, today it's very easy to start thinking about AI, but it's not what the term means. Generative means that the next state of, or the next step, the next calculated step in the process is based on some function or some previous values that you have calculated. So that's a generative process of calculating the next points on the circle curve. And it can be any function. Currently we have a function that is a circle. Function can be a square, can be a composite function, can be a double pendulum movement that becomes very creative. You can have multiple angles in the pendulum, and then the curve will be like very unpredictable, right? But then, okay, we have those points right there. What can we do with those points? We probably can draw other circles as well, like increase them, or maybe increase even more. You see where I'm going with that? Like if we start playing with radiuses, with densities, with some parameters, add some randomness, you're gonna get those simple pictures, and the process itself is very simple. But we are applying some math right there, and that is turning the people off a little bit. Although it's very simple, right? You can do it once and just play with the values and change formulas and so on. So this is a screenshot of this process made with OpenRender, a framework that we are going to talk about today. And it looks pixel perfect. There is no mistakes, right? It's very distilled, I would say. What if we add some randomness? Can you distinguish the difference between the shape on the left and shape on the right? Do you see any difference? Subtle differences, right? A little bit. You see, when you draw something by hand, those nanometers that you make with a compass, like the needle that moves over the paper, even if you measure something that is really perfect to take the best compass ever, there will be nanometer differences when you needle the paper. And still it will start shifting by a fraction of little fraction of a millimeter. So when I tried something programmatically, creating something programmatically that I do with a hand, it became like, it lost the soul, I would say. It didn't feel like so warm anymore. You actually want some randomness in there. So if you talk about randomness in computer graphics, you immediately start thinking about fractals as well, because this is where randomness actually is playing a lot. But even here, like with a little touch of randomness, you start getting better like gaps. Let's say they are like minimal difference between the gaps right here. And if you start drawing more circles with even less of the intervals, you start getting something like, let me see, maybe it's visible here. Okay, zoom doesn't convey the whole idea, but you get the point. You probably can see that there are some shapes appearing within the circles, right? So let's see how can we apply those interesting principles and experiment with a framework that is created not specifically for this use case. This use case is like doable with any programming language like Logo or like the ancient one, or you just take anything that can draw on a canvas and follow those ideas, and you will get a lot of interesting shapes and look at geometry, and you will learn about, I don't know, differential equations and some interesting graphs, and then you can follow those equations or functions and plot them, and you will get something like this. What I want to do first, I will not actually code manually so much. I want to show examples. So this is, I want to zoom in a little bit. So this is exactly the same drawing I just was showing on the slides. What we have here is a for loop that after every three steps will draw a circle with some offset, the calculated coordinate for the point, and some random thingy. So I actually should have done a little bit of introduction what OpenRender is. Let's do that. So OpenRender is a framework made by Studio in Netherlands for creative coding, and it actually features a lot of interesting integrations for various devices, for various inputs and outputs, and literally they do a lot of interesting artworks, projections, light shows, and everything, because they have integration with musical instruments via MIDI protocol. They have integrations with DMX controllers for light shows, and so on. So, and there are like support and integrations for pose detection applications using neural networks. But today we are going to stick with some basics And, well, maybe you will like it and then experiment further afterwards. They have a pretty complicated project setup, and therefore, to start with OpenRender, it's better with the GitHub template. They have it in the documentation, how to get started. There is the GitHub template, and when you make a fork of that or create your own repository, you will get a project with 2 classes. Basically this one, like this, simple one, and just another program as well. Let me run the demo program first. This is what you get out of the box, right? Like a demo project. Just a simple animation, but you start learning the principles right there. They have 2 kinds of DSLs. One DSL that they usually offer to start with is the program block, where you start writing the logic of animations or whatever calculations you want to do. And another one is the Olive program. It's actually OpenRender Live program, but they called it Olive. And this block reloads itself without restarting the program. So when I start typing something and there's a little process running in the background that parses the program and injects the like whatever drawings I have specified into the program immediately without the restarts, which actually gives the ability to do live shows with coding. Like if you have heard of musical shows, like programming music, you can do the same with stages or like animations and the other interesting setups. So where we start, exactly that same manual calculation for every circle or every point on this circle. This is the calculation process, right? We saw it on the slide. Like we are calculating the next point based on the angle that we decide to take using the for loop, basically angle 0, angle 3, angle 6, and so on. And if I run it, I probably should have done it a little bit bigger. You see there are some random gaps between the circles that we just draw. And just to demonstrate how the Olive program can change our picture, I'm not recompiling it or rerunning. And you see the picture changed, and now we can do like 1. It was reloaded, the density is becoming even bigger. You can experiment with float parameters, make it a little bit more hairy, more randomness, or like stupidly more randomness. But you see, like in this chaos, you can actually get a lot of interesting results. In creative coding, especially when you work with visualizations, sometimes when you make a mistake, you get a better result that you didn't anticipate getting. And this kind of randomness actually demonstrates that as well. When I was preparing, I thought, okay, I play with the subtle randomness, like 2.1, like to slightly, to make the random slightly, or those offsets slightly different. But even this, like 2.1 coefficient is actually too much. I can do better with my hand. I can do something like 0.9 probably. Yeah. So if I do something with my hand, this would be a bad drawing of mine. Maybe even like 0.7 fluctuation. Yeah. So this would look like I did if I draw this by hand manually. So it adds some soul to the result, basically. Let me see. Okay. But what we did here currently is all manual. We were calculating the points manually, and this is just like if you have a framework, if you have a tool, can't you like add more abstraction? So I did this on purpose right now to just do the introduction, but in fact the framework, the library itself provides a lot of tools and abstractions to hide this math away from you. So what we can do here, for instance, I probably should explain the DSL a little bit. So there is the Olive program where everything is happening, but there is also the extend block. And the extend block is where redrawing is happening at the maximum speed, usually 60 frames per second. And underneath it uses OpenGL actually. And everything else can be done outside of that extend block to configure the screen somehow, to perform calculations and reload them as we change the program. But the whole redrawing is happening within those extend blocks. So what do we have here? We have a basic circle, right? We clear the surface. We say that the fill should be of some color, the stroke should be a different color, stroke weight, and then we draw a circle. Right? Let's do that. So we are kind of stepping back again now, and we are getting that circle in on the screen. Let me actually shift it a little bit like this. And we can actually start experimenting with this one. Like the simplest change, of course, would be playing with the color. For instance, blue. Again, no reloads, or no restarts or anything. It will take a few seconds normally. Yeah, and it changes the color. So what we can do now is, for instance, to play with the figures again, but not with math anymore. Yes, we're still using some basic calculations to figure out the positions, but we can do something else. We can say this, the contour that we have here, literally they have an abstraction in the framework to give you the contour of the figure, of the shape, and that's called, well, surprise, surprise, it's a circle. And it gives you the, like you should specify the position, right? The position, and of course the radius. So instead of drawing to the canvas directly, we will get the shape, and every shape gives you a contour, so that circle, and that will be a contour. And for that contour, we can ask that please give me circle equidistant positions. So we are not thinking of the math anymore. We say we want this many points on that contour to be present and calculate that for us. We are not playing with sines, cosines anymore, so it's abstracted for us. And for every position in that circle, we can say drawer, and maybe draw it like this. Yeah, so you can see now little circles, right? We can configure those to be, let's say, bigger. We can say that drawer fill, the fill, there should be no fill. Maybe the the stroke should be of, I don't know, magenta. Magenta should be bright. Drawer, and the stroke weight could be something like 1.0. Let's see. Yeah, cool. So now we see like we can actually do more than that. We currently generated the points and created them immediately, but we can say that for each point, we don't want to draw them. We actually want them to be drawn at once, but with some rules. For instance, let's see. Let me extract it into a variable, for instance, points. And then we can say that the drawer should draw those points, or like for all those points should draw a circle, and we will give those points to that one. So it will be kind of the same result, right? We didn't specify the style yet, so that we can fix, for instance, like this. Copy pasting is very cool stuff in this kind of programming. So you don't really care how much you copy paste, you actually care about the visual part. Okay. But what we can do here is start playing with the set of points that we actually draw. For instance, say that that's a contour, right? Contour. No. Sometimes I forget the names of the functions that they have, because they don't really match the standard library. I better switch to another example. Yeah, right here. So here, like basically the same process is following. This is what I was looking for. The contour, the curve that we just created, and I want this. I would explain in a moment what it means. Let's get back and try doing the same points. Sub. Oh, circle, exactly. No. No. Like this should take the equidistant positions as well. Let me check the curve. Exactly. I'm using the wrong. Sorry, I'm using the wrong. Function here, or maybe I mixed up the example. Sorry, my bad. Okay. So now, because of how this redrawing is organized within the extend block, it actually follows the time implicitly, and there is a variable called seconds, right? Where we can say, okay, I want the curve, the shape, or the visible shape of that curve to be dependent on the time. And if I just say seconds and multiply it by 0.9 and experiment with those coefficients, I will see that it spins faster because it's now like 0.9 speed. The length of that curve also depends on the other coefficient that I'm using here. So 0.6, for instance, it will gets slightly longer, and so on. So now we know that the framework provides us the basic shapes and abstracts us from the geometry. It has time because it redraws the canvas as fast as it can, so you can do animations. And it actually provides you more abstractions than just the basic shapes. So the example I flashed briefly in here, what you can do here, for instance, the canvas, the screen of the application itself has bounds, and it provides some utility functions, for instance, to calculate points on that square or the shape, like whatever shape you give it. So I will use the function to scatter random points across the surface. And then there is a utility function called hobby curve, which is a very interesting one. The math behind it is pretty complicated, and you will see how it looks like. And there are some like just primitives, right? Calling the fill, the stroke, just this, the style for whatever we are going to draw. Let me run the program first, just the surface without the hobby curve. So there are points scattered across the surface. The trick here to freeze them in the positions that they were drawn is to use the random of 0. If I remove that, you will see that it will just redraw all the time. Probably not exactly what you want. So you actually want frozen points in the surface. But what can we do with them? Again, like the simplest thing would be draw a circle inside each of them, or a circle and a circle of circles and so on, so you get a lot of circles on the surface. But that's not getting you giving you a lot. You probably can do better. So that hobby curve is an interesting geometric function that will take all the points and draw a line once through each of them. Calculate the path, and it will not just take like a direct stroke from one point to point, but will do the curves and calculate the curves exactly so that they look nice. And if we add that, let me add this one, and don't add this operation yet. Yeah, so initially it looks like this. Pretty neat. And of course you can do animation, like with drawing it partially and drawing depending on the time, of course. So you just redraw every time depending on the time and the different slice of it, of this curve, and it already becomes a very interesting animation for, let's say, imagine you have a light show somewhere on a big wall, somewhere you have animation like that. This is a very basic one, but you can actually make it even more flashy, visually appealing, use some effects, and so on. What else is possible here is doing some more complicated operations. The same program, slightly different. So what we do here, we take the same hobby curve, the slice of it, and find the intersections at every moment of time. Whenever the curve intersects itself, you're going to detect that intersection and extract it into another point. So you see there is like, I did a first step, I generated some random points. Now I applied some function to follow through those points. Now, when the process is happening, there will be intersections, so there are multiple steps in this generative process, depending on the previous stages all the time, where I'm deriving something constantly, and I will get new points to use for something else. And this leads us to interesting results as well. So it's slightly slower, but as you can see, the points are appearing only when we are intersecting. Right? So now we can actually start playing with that. For instance, every point that appears, every intersection point that appears, would be some sort of an effect, would create new interesting sequences depending on where it appears. So I was experimenting yesterday, and I made a mistake, again, referring to mistakes in this kind of processes that they can give interesting results. I actually wanted to do something else, but I made a mistake in my program, and it generated this kind of animation for me. So you can imagine this kind of animations being used somewhere in the wall, like maybe not so flashy, not so fast, but can actually complement the whole, like the interior of some exposition, for instance. Okay, enough of visuals. The framework offers some more interesting stuff. Creative coding is not just about finding the functions and calculating the points. It's nice that the framework abstracts all this math from us. Now we are working with sets, collections. We sometimes calculate something, but it's a basic math. There is no like geometry or like special math to calculate something, no differential equations, but you can use that as well. The creative coding is not about like just one input and one output. You can use any input. What kind of inputs you can think of? Anyone? Sorry? Sound, music. What is sound? A wave, so analog, right? So you get some kind of a music wave, you sample it, you get some signal. Out of that signal, you extract, again, some information, and based on that information, you do visuals, for instance, or generate some other music, maybe, or generate some signals for the lighting controllers that will play with the music, for instance. What else can be there? Yeah? Data sets can be data sets, right? So you can visualize big data sets, for instance, and sometimes from visualizing data sets, you can find some interesting information that how this, I don't know, facts or nodes or data is connected to each other, right? That's an interesting use case. Yes? Anything else? Video? How would you use video as an input? Oh, detect the pose, for instance, right? Like the person. So, for instance, motion controlling of something, right? You detect the motion, you detect the points, the right hand moves somewhere, and then some visualization should react on that. So there's like creative coding is not just about visualization, it's also about music, about virtually any input and virtually any output. So here I just want to show some very simple thing with MIDI controller. I don't have a MIDI controller with me, but I figured in Mac you have a MIDI setup, and then there is this driver where you can say I have a virtual bus or virtual wire inside the system, so that I can use some software that generates MIDI sequences, and I would like handle those MIDI sequences on the other side of my system and do something with them. In OpenRender, they have a few helper functions to work with MIDIs, like MIDI, like open the MIDI device, and then you can just give it a name. So my virtual wire is called live right now, and I'm just connecting to that device. And then I can use the other software, any workbench, that will write to that port. Let me see. Yeah. So in the configuration options, I will, like, the software immediately discovers that there is a virtual wire registered, and I can just say, okay, I'm going to use that wire to write into that wire. So that's my output device. And like, well, it's a usability thing. Track doesn't immediately convey the information that I will write there, but that's how Ableton configures itself. So you can use the same wire as input for yourself and output for someone else. So now we are using this virtual driver as an output, and therefore I have configured it as a tracking instance. And I'm not very good in like writing music in software, so I used Claude via MCP. Please generate me some music. I want bass line. I want some drums and so on. So it generated it for me. And all I did, I decided, okay, I need another MIDI track, and just copy paste from the bass line. So this one is generated by the AI. This one is a copy paste for to generate MIDI signals. On the bottom there, you can see there are some MIDI signals happening, like in the timeline. Good. So the process is going to write the copy of my bass line into the MIDI port that I have virtually in the system. Now, I don't know if you will hear, we tried connecting it to the room sound system. We couldn't. You probably can hear. It's a generated music. It's not something I made. Okay. And now I have a MIDI device registered in my application. And let's actually run it. It's boring to see the code here. It's always interesting to see what's the result. Maybe we can then explain what was happening in the program. I should make it bigger, sorry. I will make it slightly bigger, 1,200, 800. Yeah. Okay, so currently it's just a black canvas screen. There are options to create your own settings, like your own menu, to control some parameters if you wish to. Currently there is just a filter that I have configured. I will explain what the filter does later. But now I need to start playing. Actually, this system is already listening. The program is already listening right there. So it's like on the bottom, there are some logs saying that it connected to the virtual device. And let's try running the application. Currently, the window is always on the top. Let's see if it works. It's a very simple visualization, right? It just finds the node, distributes 12 nodes horizontally, and assigns a color. Very minimalistic, very toy example, I would say. But the framework provides you more options for playing with this kind of visualizations. And I can actually partially stop the music and tell only this thing. Oh, sorry. Only this MIDI sequence to play. And as you can see, I'm not depending on the music sound. I'm depending only on the MIDI signal. And MIDI signals are just the commands. They are encoded as MIDI events, and they are supported by JVM. So in JVM, there is an implementation for MIDI. And all you do, you parse note number, note event type, like note on, note off, and what to do with that. There is velocity. So MIDI keyboards sometimes like offer you some expressiveness on like expressiveness capabilities, so that you can type the key stronger, like push the key stronger, then you get a better velocity. And based on the velocity parameter, for instance, you can draw a bigger circle or apply some effect if it if it adds more of different parameters. MIDI controllers come also with, like you can play keys, right? The notes, you get the note numbers, but a lot of MIDI controllers can come with knobs that you can turn, and those are usually the control signals. So you can use them, for instance, for controlling your scene, the positions, the effects, and then notes could be just the visualization, the signals for the triggers for drawing something. Let's look at the code for a second. So again, it's a Olive program. There is this GUI that is for building the side panel, where I can just configure any effects or any configuration parameters that I want to change live. And one of the, let's say, practical effects that you can use is the ADSR tracker. ADSR stands for attack, decay, sustain, release. That is often used in music for, how fast the note gets, like the maximum volume, how much it should sustain the volume, how fast it should decay the volume, and what is the release speed of when you release the key and so on. So it can, when you release the key, for instance, on a MIDI controller, it can stop the signal immediately, or there should be some kind of a tail signal after that. So the approach here is used for this effect is used for animation of those circles. You see, they appear fast, but they can disappear slowly. So for instance, release, if we increase the release parameter, they are like slowly disappearing and appearing again. They don't have time to disappear before the next circle appears. Or we can just remove that, and they will disappear kind of immediately. Start playing. So using those parameters, we can control the smoothness of that animation. Again, these are very basic effects that we can see here. Like you see, they are blinking now, right? They are not smooth enough. Let's do it like this. Okay. But there are more interesting effects that you can apply. So the same program, I will add some more effects. And the effects are like laser blur, fisheye, lenses. We will start, how you call it, transform the existing shapes on the screen with some functions, right? We don't really care what those functions are. It's interesting to just plug and play those effects and see what parameters are there and adjust for your stage, for your scene. Let's run that as well. So I now applied 4 of those effects, and the result is like this, right? But we are still drawing the basic shapes there, the basic circles. If we start playing with the parameters, we suddenly get very interesting results there. The angles, right? Let's keep the angles. Maybe bring them forward, bring them back, amplify them, make them brighter. What else is there? Fisheye is an interesting one. But also the lenses. Where was it? So it breaks those parts into the pieces. How can I make it? Okay, the fisheye is probably going to now you can imagine that using these simple, very simple visuals, you can actually make very interesting installations. If you take it to the big screen, if you take it to projectors and connect it to music. Actually, some of my friends who play electronic music, they use this kind of scenes for just, for the performances. Because you can connect multiple devices and create different visuals for different compositions. With this, I hope this was inspiring for you. And as you can see, it doesn't take long to get started. Like, there's just a little bit of code. This one is a little bit more complicated, but getting started is super easy. You just have to know that circles exist, squares exist, and some numbers in collections. And you can get pretty far with that. And especially like today, the tools that can generate the pieces of code for you, like AI assistants and others, I'm like literally, I'm sometimes like feeling adventurous and tell it what I want to get, what kind of visual do I want to get, and sometimes they generate something for me that I didn't expect. That's nice and surprising. So, if you liked it, give it a try. I have the sample project on my GitHub, but you can always find some examples as well. OpenRender has a very good documentation. They have very good samples and very passionate community. So they post samples, what they achieved. In meanwhile, you can follow me on Twitter, and I have my Instagram account with the artworks right there. And they don't always have to be programmatic. You can actually make them with coffee. So thank you for coming, and I hope it was nice for you.